So welcome to my no-nonsense, no-waffle approach to the Eduqas/WJEC paper from the summer of 2024. It's component 1, or as normal people call it, paper 1, which for these lot means non-calc, so let's shut up and get on with it. When you are estimating, that means round off at the beginning, not towards the end, not halfway through. Make them easier right at the start. So 2 cubed gives us 8. Square root of basically 100 gives us 10. And that gives us 0.2. As a fraction, though, it's a fifth. How do we divide by a fifth? It's the same as multiplying by 5. 8 times 10 is 80, times 5, 400, makes a good estimate. Solve, well, we have some brackets, so let's expand the right-hand side first. 4 lots of C, 4 lots of 2. I like to do 2 things at the same time at this stage, so isolate the C's by subtracting 4 of them from both sides. Nearly wrote an X out of habit. Whilst also subtracting 3 from both sides. And we're nearly there. We just need to divide by the number next to C. So 5/7. 3a, write as a product of prime factors. I always prefer the factor trees. It's definitely in the 5 times table because of what it ends in, but it's way above what you're normally familiar with in these sort of questions. So unfortunately, either your mental arithmetic is better than mine, or to make sure you're getting it right, do your bus stop to get 495. Again, ends in a 5, so let's divide it by 5. Now it's almost 500. If it was 500, dividing by 5 would give 100. We're 1 5 fewer, so it's got to be 99. And if you don't spot that, more bus stop. You could go 9/11s, but I'm going to go for a 3-way split to speed the process up. And finally, it wants it in index form, must use powers. These don't have to be in this order, but when you write your 5, it's got to be 5 squared. And when you write your 3, that's got to be 3 squared. Part B, to square root a number that's way beyond your mental arithmetic, you just square root each component. So the square root of 64 is 8, but because we're told to use index form, we rewrite 8 as 2 cubed. When you square root a number, you can just halve the power. Why is that? Because square rooting and power of a half mean the same thing. And when you're square rooting, you're basically taking the power of 4 and multiplying it by a half. So we get 5 squared. And the same for the 7 to get 7 squared. Number 4. Give 2 reasons. I'm not going to read through the scenario. Give 2 reasons why the graph is misleading. Well, firstly, the y-axis starts at 55. In the olden days when I was at school, it was called a false origin. Seems like that phrase has died out now, but I'm going to stick with it because I'm old and I'm too old to change now. Next, well, as you can see, July, August, it's only these months with the positive trend that have been plotted. These months, with what is generally a downward trend of sales, hasn't been plotted. So words that explain half the data, or words to that effect, or only showing the bit which fits your narrative. It's a biased part she's doing. As I always say for these questions, don't feel like you've got to fill 3 lines. Keep it simple. I would just say she's only done the last 6 months and ignored the first 6 months. Number 5. Question and response. What I would say to these is you can phrase it in lots of different ways It's more about the things not to do than the things you should do. Don't have response boxes which have overlaps. You don't want to have 0 to 10, then 10 to 20. Where does the 10 go? What I would suggest when you do your response boxes is, first of all, don't have too many. I've gone on my written out answers, I've gone for a 0, and then I've gone for a above 0, so doesn't include, up to 10. Now you could do that as 15 or 20, no one really cares. Then I've gone for an above 10 to 25, and so anyone paying £25 would be in that group, and then greater than 25. So it means I've got no overlap, but also I've covered all possible options. And for the question, do make sure you give a time scale. Don't just say how much you spend on gym membership. All right, actually put the time scale in. How much do you spend on gym membership per month? Part B. Again, you read all that waffle. I've had the unfortunate pleasure of having to read it already. Explain why the mean is not the best. The mean is always skewed by extreme values. Not quite outliers, but they're getting there. So anything that says it will be better to use the mode or the median, as that ignores these particular 2 people, maybe even those 3 people, if you want to, pick on those. Give one other reason why Joe's results may not be reliable. He's only sampled 15 people. Also, some adults, not picked anyone of any particular age, but I would just stick with 15. It's quite a small number. You could criticise how he sampled them, but it doesn't really give much detail. Doesn't say he stood outside the leisure centre, which would give you a bias. Doesn't really say that. So yeah, I would stick with a small sample for 15. Number 6, they love their waffly words, these. It's quite a difficult one for me in order to understand. Once you get the first line written, it then becomes quite nice. But the idea is, for 30 minutes times X, something's happening, and it is going to take, because you can't overfill it. Once it's full, it's full. So that will fill it, but so will 40 minutes of that. And that's how you settle the equation. Times the brackets out. 40 times minus 2 minus 80. Adding 80 to both sides. Subtracting 30x. We get the value of x, but no celebrations just yet. We've solved it for x, hence find the capacity. The capacity is either sub your x into there, or there, same thing. And I'll just go for the easiest. That 30 times 8 is 240. Number 7. To go from a ratio to a fraction, we're only interested in J. J is the third person, so that's 11 out of the 3 plus 7 plus 11, 21 shares. Part B starts giving information. For me, I would start writing it out, getting it organised. L, K, J, yep, they've done it out of alphabetical order, be careful. In the ratio of 3 to 7 to 11, J spends 45, now has twice as much as L. Well, L is 3, so J will get to the point of being 6 of the shares. That is 5 shares loss, which is worth £45. That's the key connection, which means 1 share is going to be £9 K has 7 shares. 9 times 7. A lot going on in that one, but getting it organised, there's other ways of doing it, by the way, but getting it organised, you're halfway to solving it. Number 8, also lots of waffle. So P and N, they're not zero, one's positive, one's negative. So let's look at the top line. Well, if P is negative 2 and N is positive 3, they're going to be totally different. But at the point where they're plus and minus of the same number, like 5 and negative 5, it would be true. So the top line is a sometimes true. P is less than N. Well, P stands for positive. So P will always be above 0. N will always be below 0. So by definition, P will always be larger. It's never true. N divided by P. One's positive, one's negative, and when you divide them, you get a negative answer, no matter what they are. So a negative is always lower below 0. So that is always true. N squared greater than P cubed. So again, you've got the situation where when you square a negative number like minus 10, you get quite a large number, 100. And that could easily be greater than 2 cubed. But you can also think of numbers where it's not true. All right, if n is minus 1, and you square it, you get 1, but p is 2. There you go. So this is another one. It's sometimes true. Part B, reciprocal. That means numerator becomes denominator and so on. In other words, you flip it, but you can't do it while it's mixed. So job 1, change it to top heavy or improper, and then you reciprocate it. You flip it upside down, and you're done. Part C, anything to the power of 0 is 1. Don't even waste any more time on that. In number 9, we're not told how many booklets are being printed, so I'm just going to refer to them as printer minutes. To print all the booklets required in this job, we need to do 36 times 6, either in mental arithmetic or do it by standard, any form, any method you want, as long as you get 216 printer minutes, or call it whatever you want, even nothing. To print half as much, half as many booklets, we need stuff doing so half the time. 108 printer minutes are required. How long will it take 9 printers? Well, divide it by 9. And there we go, that's all it is. 9 printers working for 12 minutes. Whoops. And you're done. 10A, we have a reverse percentages question on a non-calc paper. So what? Your percentage reduction is 25%. So the original amount multiplied by your multiplier would be 0.75, but I prefer fractions. I think they're easier to manipulate when you haven't got a calculator. So starting unknown starting price times 3/4 gives you £54. You can now unpick this to get X. Times both sides by 4, divide both sides by 3, or if you prefer, divide by 4/3, times by 4/3, or divide by 3/4, then you'll have to flip it anyway. No one cares. You'll end up with £72 if you do it correctly. Part B, I'm a big believer in think of percent and pence as the same thing. So if you're trying to decrease something by 33%, take 33 pence away from a pound. That gives you your multiplier, so 0.67. It's also never a negative. You can instantly get rid of them. Part I, if you're increasing by 6%, you add 6 pence onto your pound, but to do it 3 times, we need power of 3. Number 11. Long and waffle, and this extra line of working out, ignore it. One line at a time. We've got 3 apples and 4 bananas for £2.70. 2 apples, 3 bananas, £1.95. It's simultaneous equations. I'm choosing to make the number of apples the same. So I'm going to double the top and treble the bottom. Doubling the top equation, 6, 8 and £5.40. Trebling the bottom, 6A, 9B. Treble £2, you get £6. So we take off 15 pence from £6. Or do your own method for multiplication over here. Upside down for me, I'm going to do bottom take away top. Why is it a takeaway? Because we've made the A's the same as in 6. They're both positive, same sign, subtract. Bottom take away top, 9B take away 8B, 1B, and subtract those. We get 45 pence for a banana. Pick any of your original 2 equations. I think on my original one, I went for the bottom one, so let's do the same again. 2 apples, 3 bananas, so 45p, 90p, £1.35 is £1.95. The difference, take away £1.35, 2 apples are 60p. 1 apple is 30. Normally, simultaneous equations, you've finished. You've got your x and your y, in this case your a and your b, but not here. We now need to do 4 apples and 2 bananas. 4 apples, £1.20. 2 bananas, 90p for £2.10 or 210 pence. Number 12. When you are multiplying or dividing numbers in standard form, you divide the numbers that are between 1 and 10 and then apply laws of indices to the powers of 10. So here we need to do £1.29, divided by 3. Again, mental arithmetic or whatever, bust up as I've done. We get 0.43. Now that's going to need to be adjusted. It is not between 1 and 10. But let's do powers first. It's a divide. We are subtracting the powers. We should be doing 5 take away -7, giving us 5 plus 7. But now you've got to adjust it. I want to make this bigger, so I'm going to multiply this by 10. That gets me between 1 and 10. But I'm going to need to divide this by 10. Or in other words, take 1 off the power. Part B. Choice here, you could just write them out in full. Do it and then convert your answer back. I'm going to show you the adjustment method. They'd be dead easy to add if they were of the same kind. Just like 4 million take away 3 million is easy, but 4 million take away 3,000, not so easy. There's lots more to think about. So if this 3 times 10 was of a different form, as in we made it bigger, we'd have to make the 3 smaller. But now they are of the same kind. The answer is going to be power of 5. We just need to do 7.6 plus 0.3, 7.9. Got to be honest, not really a shortcut. If you don't just write them out in full, you'd get there and it's not a big problem. Powers of 2, let's adjust both. So 32, 2 times 2 is 4, 8, 16, 32. 2 to the power of 5. Power to a power means multiply the powers. Finally, we can just add the powers and we're there. Number 14, lots of ways of going about this. That is an equation that factorizes, as in n plus 1, n plus 2. So you can make the argument that these two numbers, while being consecutive integers, the only scenarios are even, odd, odd, even. So when you times them, it's always an even answer. Or you could take the situation where n is even, when you square it, even, treble it, even, and add 2, it's even. And when n is odd, odd squared is odd. 3 lots of odd is odd. But 2 odds added together plus 2 also make even. Choose your favourite. Alright, choose whichever way you think you can explain in the fewest amount of waffle. Part B. If you want to go the long way about this, feel free to just go count them up. There's 3, there's 6, there's 11, there's 18. It'll work. Do the nth term of that. If you want to spot the quick way, pattern 1 is 1 with 2 on it. Pattern 2 is 2 squared with 2 on it. Pattern 3 is 3 squared with 2 on it. And pattern 4 is 4 squared with 2 added onto it. So you take the pattern number, square it, and add 2. But you'd get there anyway, and it wouldn't save a great deal of time doing it either way. Number 15a, explain why her statement cannot be correct. Proportion, that's the key. The graph seems to be doing that kind of shape, also known as a reciprocal graph, but more importantly, this graph shows inverse proportion, not any form of normal or standard or direct proportion. On to B. They're positive, so that means if you're going to square root it, ignore the minuses. But let's crack on. P is inversely proportional to the square root of Q. We're told that P is 36 when Q is 25, 25 rooted, and we've got C, 5 lots of 36, 180. We have our formula. The square root of Q. And now for part II, you've just got to sub it in. If you replace the Q with 9, you'll get 180 divided by 3. Bit harder for this one because it's the other way around. So let's replace P with 45. Times both sides by the root of Q. Divide both sides by 45. And that's nice and easy. Worked out okay. And we get Q to be 16. Onwards. Number 16, lovely clip art and loads of nonsense going off here, so Yeah, feel free to take half an hour of your life to read this essay of a question. The key bit is there. The number of large tables must be less. So large must be less than double the small. And restriction 3, total number of seats. Total seats, not tables. 4 lots of small and 6 lots large must be less than 120. On the graph paper opposite, I've already drawn them. I've cut and pasted it from my original. How did I do it? Well, condition 1, that's easy. You've just got to plot L equals 12. That'll just be a horizontal dotted line going through 12. To plot L is less than 2s, you need to plot L equals 2s. So when you do a table of values, just treat it like x and y's. It's going to go through 0, 0. And when s is 10 or 5 or whatever, you just double it for your large. For this one, this connection, a little bit harder, but same process. When s is 0, for example, and they all disappear, 6l equals 120, L must be 20. Now, if you pick any awkward numbers over there, you will start to get fractional answers, but it won't affect your final answer too much. But 6 is the clever one, because why have I picked 6? 4 and 6, 24, take away 96 was my target, so I wanted to take away 24, but that's just waffle. When that is 6, that is 16, because 16 sixes plus 6 fours are 120. That's what it looks like. Needs to be dotted lines because of the fact that it's greater than, not greater than or equal to. Part treble I, the owner is superstitious, doesn't want 13 large tables. From your graph, find the correct answer. 13 large tables is here. So we now know these 4 possibilities are no longer a possibility. And so that one lies on the line, by the way, as does a couple of others. It's got to be that circle there. And that circle, as you can see, I've gone down, is 8 small tables and 14 large tables. Heck of a question and a big pain in the backside. And we're not finished, although it is a bit of a totally different new question. On the opening night, etc., etc. There are 110 customers. 9 had to wait between 0 and 15 minutes. That's the bar that needs drawing. It's not drawn. How did I know to put the green line in there? Because the area of the bar is supposed to be 9. The width of the bar is 15. To work out the height of the bar, you do area divided by width. Thankfully, it cancels down to 3/5, which you should be familiar is 0.6. Next bit is about percentage. Whoops. Calculate the percentage. Well, percentage means out of, so let's write it as a fraction. It's really saying how many of the customers out of the 110, it'll be times by 100 to turn it into a percentage, had to wait longer than 30 minutes. We're interested in these 2 bars. We need to find their area. So this bar here, it's 10 wide, 2.6 high, 2.6 times 10. This bar here is 20 wide, 0.9 high, 9 lots of 20, 0.9 lots of 20, 18. Meaning we have a total of 44 people. Numbers aren't the best, but when you realise you can cross a 0 off the top, 0 off the bottom, and 44 over 11 is 4, we just do 4 times 10. And on we go. Number 17, to factorise that, it's the AC method. A is 3, C is negative 20, so AC is negative 60. I always prefer to create some room. So move the 3x squared to the left, the minus 20 to the right, and chop your page in two. We need two numbers which multiply together to make minus 60, but add together to make positive 7. Start making a list. I did, and I ended up with positive 12 and negative 5. I've split it in two because now you need to factorise the left-hand side. So there's a 3x in common. And factorise the right-hand side. They've got a minus and a 5 in common. And if you've done it correctly, these brackets should self-check and be the same. So 3x times x gives us 3x squared, and 3x times 4, nice one, minus 5 times x, yep, and minus 5 times positive 4, yes. So one of our brackets is x plus 4, and the other, I refer to it as leftovers. But it does say, hence solve. One of our solutions is change the sign, negative 4. The other solution is change the sign to get 5, but then divide by the number next to x. Number 18, because we needed a picture of loads of cheese, didn't we? Otherwise, who'd have known? Surface area of a cylinder. There's a circle on the top and a circle on the bottom. We need to find the area of the top and double it. The area of the top is pi times the radius squared doubled. The side though, if you've ever took a label of a tin of beans, tin of soup, the area of this is the height, which is 7, multiplied by this distance there is actually that distance there. In other words, it's the circumference of the circle, which is given by 2 times pi times the radius, which is 12. Give your answer as a multiple of pi. So let's just take them out. It's surface area, so centimetres squared. Your job is just to work out 2 lots of 144. And 7 2s are 14, and 14 times 12, 168. Do some short multiplication if you want. Those two numbers added together, 456 pi. For part B, looks a lot worse than it actually is. You're basically looking at a cylinder and a wedge, which is a fraction of a cylinder. Let's do the wedge first. The wedge, the volume of a wedge will be pi times the radius squared. We don't know what it is, but that is the area of a full circle. We don't want the area of a full circle and we also want the volume. So we have to times it by 8, because that's its third dimension, and we multiply by the fraction, which is 30 over 360 degrees. In other words, a 12. Let's tidy this up. R squared and pi, 8 over a 12th is, we divide by 4, is 2 over 3. We've done the wedge, now let's do the hole. Hole's a lot easier. It's pi times the radius squared times by the height, which is 25. Which is 25 pi r squared. Work out the volume of the wedge-shaped piece as a fraction. That's why I set it out like this. Fraction means over, and the pi r squareds all cancel. 2/3, if you want to divide a fraction by 25, you simply multiply the denominator by 25. As I said, I think it looks a lot worse than it actually is. Number 19, waffle, waffle, waffle. As always, at the end of the day, what have we done wrong here? Well, the probability of passing exactly 1, 0.6 times 0.3, refers to passing Spanish and failing French. So you need to add in, she hasn't considered failing Spanish and passing French. In other words, she's missing out 0.4 times 0.7, and so on. Calculate the probability of, oh, here we go. You've got the 0.18 from the previous bit, but we need to do exactly what we've just explained in here. 0.4 is failing Spanish. 0.7 is passing French. That gives us 0.28, and 28 plus 18, 46, or 0.46. Part B, again, lots of waffle, 4 marks, not a lot of room to do it in. The key bits for me, knows the answer to 60%. We haven't got a calculator. 10% of 75 is 7.5. 60% and 40% are going to be needed, because if they get 60% correct, they're going to get 40% incorrect, and then it comes down to pot luck. Let's times the 10% by 4, so double it and double it. And if 30 questions are basically going to be guessed, then 45 are going to be given as correct. Now let's work out the total correct. 45 are going to be smashed. Nice one. Of the other 30, of meaning times, there are 5 possible answers, so it's a 1 in 5 chance. 1/5 of 30 means they're going to be getting 6 correct. So we're going to expect 51 correct answers. The probability of a random answer being correct, therefore, is 51 out of 75. Yeah, just waffle for the sake of it, really, isn't it? Number 20, you could use a diagram, or hopefully you've just learned them, but that might be wishful thinking, depending on the time of year. Cos of 30, if you don't know how to use it, cos, don't forget, is ca. So from your 30 degrees, which is there, it's adjacent over hypotenuse. You're going to need your hypotenuse of 2. You're going to need your opposite of 1. You're going to need to do Pythagoras. 2 squared minus 1 squared is root 3. And if you want to, so adjacent over hypotenuse is root 3 over 2. So I just think quicker to learn it. Tan 30, tan is TOA. So similar, same triangle you can use, except for tan, it's going to be the opposite, which is 1, which is 1 over adjacent. So 1 over root 3 is a correct answer. If your teachers are nagged to rationalise root 3 over 3, they are the same thing. On to part B. I've already had a little play with this, as you can see. I tried to colour coordinate it so that green goes with green. Because the thing with 3D trigonometry is finding the triangles. And I always think it's a good idea to redraw them so you can better target what you're after. The diagram shows a cuboid, okay. B to D, that's this line there, is 10. A to C, that's the bottom line, is 12. DBC, that's the little acute angle, in there is 30. And here's a nod. 30 degrees, folks. That's what it wanted you to be looking towards. On this first diagram, the connection is, whenever you've got two triangles, try and find the line they have in common. It's all about this C to D. On this purple triangle, that's the opposite. Hypotenuse, adjacent. We're not interested. So this is a SAW. Question. We want our opposite. We do sine of the angle, sine 30, already given in your table above as a half, multiplied by the hypotenuse. Oh look, what a nice answer. We can carry that CD forward because it's now there. Calculate the distance, AD. AD is the hypotenuse of a right-angled triangle. We need to square the two sides we are given, add them together, and these are numbers I'm sure you've seen before. 144 plus 25 is 169 rooted. It's an old friend, 13 squared. Number 21. It's writing them as a connection, getting an equal sign that will help you on this. If the mean of 3 values is that, then their total is treble that. So we can write that x added to 12 over root 3 added to the root of a half all to the power. Well, root of a half, not a fan. But if we're going to do root 3 times root 3 times root 3 times root 3 times root 3, we're getting 3 lots of 3. And that's a lot easier. 9 root 3. And they all add up to give 18 root 3. Firstly, let's rationalise. 12 over root 3. If you multiply the top by root 3 and the bottom by root 3, we've got 12 over 3, which is 4. And you can see all the pieces of the puzzle coming together. X must be some root 3's, 4 plus 9 plus some number. That number that we're after is going to be 5. That's how we get the 18. A couple of ways of, jiggering and poking them around, but that'll do the job. Turning point, we have to complete the square. It's quite helpful that they tell you, to be honest. Some exam boards, not so generous. Halve the number next to x, square it and take it away. We now need to simplify. You've earned a couple of marks. Minus 49 plus 70 is positive 21. Turning points occur, also known as the vertex, by the way, is when the brackets have a value of x such that they disappear. So a negative 7 would mean it disappears, and when it disappears, the y-coordinate is 21. Number 23, vectors, not drawn to scale, but use it as an idea. RQ, that's where I start. As soon as it says RQ, to go from R to Q, you do Q minus R. 4F plus 3G minus all this means all the signs must change. Minus F minus 5G means we've got 3 F's and we've got 3G, take away 2, take away 5G, means we're into minus 2G. Now if you compare them, RQ equals something times this. How do we times and they get smaller? It's got to be a fraction. And as you can see, they're each dividing by 3. The fraction is a third. Write down 2 facts about the lines OP and RQ. Well, because they are a multiple of each other, fact number 1, they are parallel. And fact number 2, I'll just scroll up a bit. OP is 3 times the size. Or flip it around, that RQ is a third of the size of the other one. Depends on which side you want to take it from. Next, O is the midpoint, which if I just scroll it down, if O is the midpoint, there must be something else, and that's what we're talking. So the idea is to go from here to here, we need to reverse this arrow and double it. So the 9F becomes negative 18F, and the minus 6G becomes positive 12G. 1 mark for each bit, just that bit of logic really, more than any complicated workings out. And number 24, just for fun, I'm going to attempt to do sketches live. So deep breath. What does that do to a curve? That is a translation. It's going to move it, in this case, horizontally, and it's always the opposite way round to what you expect. So x minus 3 means it's moving right 3. That bit of knowledge gets you a mark, so as long as you don't murder what I'm about to murder, you'll get the other mark. The x-coordinate needs to go up to be positive 1, 0. And then just try and do something. And keep it parallel. You don't need crossing it again. I think I'd get away with that, but hopefully yours is a lot better than mine. And finally, part B, two things going on. When an entire function, not just the x, when an entire function is multiplied by -1, that results in a flip, a reflection in the x-axis. So firstly, if you drew it on, if it was just that, that's where it would be. But we've got a +5 in the end. And unlike part A, a +5 on the end is a translation, but it's vertical. It's moving it up 5. So flip this upside down, moving it up 5. Scale not important. What's important is the general decent shape and labelling where it intersects the x-axis, the y-axis. You knew what I meant.